Good evening, one and all present here. Myself, Viswam Patel, roll number 102, GIA, Department of Chemistry, School of Science, Gujarat University, guided by Dr. Hitesh M. Parekh sir. Today's my seminar topic is pericyclic reactions. Topics covered in this presentation is introduction of pericyclic reactions, characteristics of pericyclic reactions, types of pericyclic reactions and briefing. Introduction. Application. Pericyclic reactions are known as periphery of the ring. Periphery means outer surface. Reactions which takes place at outer surface of the ring is known as periphery. Pericyclics are derived from ancient Japanese word peri and cyclos. Pericyclic reactions are reactions in which simultaneously bond breaking and bond forming takes place at outside of the ring. Here I am taking two graphs. One is multi-step reaction and another one is concerted reactions. In multi-step reaction, as you can see that there is a graph between energy versus reaction coordinate. In multi-step reaction, as you can see that many transition states are possible and also intermediates. So here starting material is here reactant. So here transition state, here intermediate is forming, here also transition state, here intermediate is forming, and here same wise transition state, and here product you will get. So here three transition state and two intermediates are formed. So here in concerted reactions, here reactions takes place only in single step via cyclic transition state. Here starting material, and here transition state, and here product is obtained. Here as you can see in the graph, here no intermediate is formed, but in multi-step reaction here intermediates is formed. Pericyclic is derived from two words, peri and cyclic. Cyclics mean cycle, or we can say like closed system. Peri means outer surface, or we can say like periphery of the ring, means outside of the ring, and it gives cyclic product and vice versa. Characteristics of pericyclic reactions. These reactions are concerted reactions. Concerted reactions means reactions which takes place in single step. Okay, it takes place under thermal or photochemical conditions. Here thermal means heat, and photochemicals HN. It does not require any acid or bases to initiate the reactions. This reaction can be initiated either by light or thermal conditions. Here no intermediate formed during reactions, for example carbocation, carbanion, nitrine, carbene, etc. It is independent on the nature of solvent and catalyst. As you can see that many chemical reactions are initiated by reactant and solvent with the help of catalyst, and proper temperature we require to initiate the reactions and convert it into the product. But here it is a special type of reactions, pericyclic reactions. Here no intermediate is formed during the reactions and no solvent and no catalyst is required during the reactions. It is only generated by the light or thermal conditions. Here stereochemistry of reactant should be maintained in the product because its concerted mechanism operate. So here above statement tells that if in the reactant we are taking cis geometry, so we will get in product cis product. Means if you are taking trans geometry, then you will get trans product, because here stereochemistry of reactant molecule is maintained, means same in the product. If you are taking cis, then you will get cis product. If you are taking trans, then you will get trans product. Types of pericyclic reactions. Pericyclic reactions is classified into four categories: electrocyclic, cycloaddition, sigma-tropic, and group transfer reactions. Electrocyclic reactions. Electrocyclic reactions means it takes place under thermal or photochemical conditions. It involves the cyclization of conjugated polyene under thermal or photochemical conditions. Here intramolecular cyclizations take place. Here number of sigma bond increases. Some example of electrocyclic reactions are there. Here I am taking two example, ring closing and ring opening reactions. In ring opening reactions means closed structure is converted into the open chain structure, and ring closing reactions means open chain structure is converted into the closed structure. In any pericyclic reaction, you have to first of all remember which system is there in the reactant. Means it obeys 4n pi electron system or 4n plus 2 pi electron system. First of all, you have to remember which system is given in the reactant. So here, first of all, we discuss example of ring opening reactions. Here, as you can see, here is the closed structure and it is converted into the open chain structure. Here, as you can see, here the pi bond is converted into this. So you will form here pi bond. This pi bond is shifted over here, so you will get pi bond here, and this sigma electrons is converted into this, so here you are getting pi bonds. Here 4 pi electrons plus 2 sigma electrons, 4 pi electrons from 2 pi bonds, so 1 pi bond contribute 2 pi electrons. So here 2 pi bonds contribute 4 pi electrons, and here 1 sigma electron is breaking, so here 2 sigma electrons are used. So total 6 pi electrons. 6 pi electrons means according to Huckel's rule 4n plus 2 pi electron system where n value is 1. Here cyclic transition state is occur like this. Here reaction is initiated by thermal or photochemical conditions. These reactions reversibly also possible like this. If you are doing this like here sigma bond, here this pi bond is converted into here, and this pi bond is converted into here. So you will get this. Same way as here 6 pi electrons, 4n plus 2 pi electrons where n value is 1. Ring closing reactions means open chain structure are converted into the closed structure. Here this pi bond is converted into here. So here sigma bond is forming like this. This pi bond is converted over here. So here pi bond you are getting. So here 4 pi electron system, 4n pi electron system. So here where n is equal to 1, 1,3-butadiene system we are taking as an example of ring closing. Here cyclic transition state is there. Here 2 pi electrons from the 1 pi bond and 1 sigma electrons, 2 sigma electrons we are there. So 4n pi electron system where n is equal to 1. Cycloaddition reaction. Cycloaddition reaction, 2 pi bonds are converted into 2 sigma bonds. It involves contribution of 2 unsaturated moiety and gives cyclic adduct under thermal or photochemical conditions. Diacetyl reaction is one of the best example of 4 plus 2 cycloaddition reaction. As we are knowing that in diacetyl reaction, diene and dienophile are converted to each other and giving cyclic adduct product. So here diene 4n pi electron systems. Here this bond is shifted over here, so here you are getting sigma bond. Here this pi bond is shifted over here, so here you are getting sigma bond, and here this pi bond is shifted over here, so you are getting here pi bond. So 4 pi electrons from diene and 2 pi electrons from dienophile. Total 6 pi electrons. So 4n plus 2 pi electrons follows according to Huckel's rule, where n is equal to 1. Here cyclic transition state is occur. Here 2 pi bonds are converted into 2 sigma bonds, like as you can see that here in reactant here 3 pi bonds are there, but in the product you will only have 1 pi bond and 2 sigma electrons are formed, right? So here 2 pi electrons are converted into 2 sigma electrons. Here pi 4 supra and pi 2 supra. Here modes of addition are there in cycloaddition. Here two types of modes of addition are there. Supra-supra addition or intra-intra addition. Supra-intra addition also be there. But here we will discuss only supra-supra addition. If same lobes are connected to each other on same side, then it is called as a supra addition. If same lobe are attached to the same side are known as supra-supra addition. Here it is a supra-supra addition. Cycloaddition reactions, intermolecular and intramolecular reactions are taking place. I am taking here example of intermolecular and intramolecular reactions takes place. Here in intermolecular reactions, unsaturated moieties are converted into the sigma bonds. So here this pi bond is shifted over here. So here you are getting sigma bond. Here this pi bond is shifted over here. So here you are getting sigma bond. So here 4n pi electron system total, 2 pi electron system, 2 pi electron system. So n is equal to 1, 4n pi electron system. Cyclic transition state is occur like this, pi 2 supra, pi 2 supra. 2 pi are converted into 2 sigma. Like same wise you can break this bond like this, and you can also sigma bond this bond break like this. So you will get this type of reversible reactions is also possible. In intramolecular reactions means reactions which takes place within the molecule. Like this pi bond is shifted over here to make sigma bond like this, and this pi bond is shifted over here like this. So here 2 pi electrons, here 2 pi electrons. So total 4 pi electrons. So system is 4n pi electron systems. Here 2 pi bond are converted into 2 sigma bond. Here 2 sigma electrons, 2 sigma electrons. So total 4 sigma electrons, 4n pi electron system where n is equal to 1. Here you have maybe question arise like which type of reactions is taking place in different cases. If you are taking any questions like, so you have to must remember that in electrocyclic reactions intramolecular reactions takes place, but in cycloaddition inter and intramolecular reactions takes place. So if you are doing a intermolecular reaction in electrocyclic reaction, then you follow wrong pathway. So instead of this you should have to remember like this. So in electrocyclic reaction intramolecular reactions takes place, but in cycloaddition both inter and intramolecular reactions takes place. Next one is sigma-tropic reactions. It involves the migration of sigma bond within pi framework under thermal or photochemical conditions. Migrating group is always migrate from sp3 carbon to sp2 carbon. Here migrating group I am taking group G. Here migrating group which is breaking and joining to other atoms, so its hybridization remains maintained. If you are taking group G here sp3 hybridized carbon with attached to carbon number 1. First of all name all these carbon atom. So here 3 possible sigma-tropic reactions are take place like 1, 7, 1, 5, 1, 3 sigma-tropic reactions. First of all we are discussing 1, 7 sigma-tropic reactions. First of all you have to just do like this. Group G is attached to carbon number 7. So here pi bond is shifted over here. So here you will get pi bond like this. This pi bond is shifted over here. So you will get pi bond like this. Here pi bond is shifted over here. So here you will get pi bond. Here group G is also in sp3 hybridized. And in reactant molecule group G also in sp3 hybridized. But the migration of group G is taking place sp3 hybridized to sp2. Here it is sp2 hybridized. Then we will discuss for 1,5 sigma tropic reaction. Here group G is shifted to C5 carbon like this, and here this pi bond is shifted like this. So here you will get pi bond. Here pi bond is shifted like this, so here you will get pi bond. Same wise 1,3 sigma tropic is also possible. Here I am taking order which reaction is possible. So in question you are giving 1,3, 1,5 or 1,7, then you have to just go through for 1,7, because 1,7 sigma tropic is more stable compared to 1,5 and 1,3. Reason is that here, as you can see, 1,7 sigma tropic, here conjugation is maintained between carbon number 1 to carbon number 7, but in 1,5 here conjugation is maintained only between carbon number 1 to carbon number 5. So here 1,3 sigma tropic, here carbon number 1 to carbon number 3 conjugation is maintained. So as you know that conjugation is increases, so stability is also increases. So that's why 1,7 sigma tropic reaction group transfer reaction is taking place to 1,5. Group transfer reaction is a pericyclic process where one or more group of atoms is transferred from one molecules to another. They can be sometimes difficult to identify when separate different reactant molecule combine to give a single product molecule. If we can say that many reactions are possible, different moiety we are taking in the reactant and we get product. But if we want to identify product molecules from the reactant, so we can't identify which reagent we are using earlier. So in group transfer reaction, it is not comparable, we can say, like which reactant we are using, because here different reagent we are using to give different product. So unlike other pericyclic reactions, group transfer reactions do not have specific conversions of pi bond into sigma bonds or vice versa. So here group transfer reaction is less frequently encountered. As you can see earlier, cycloaddition, 2 pi bonds are converted into 2 sigma bonds, but here this can not be possible. Here I am taking example of aldane reaction, or we can say in reactions. Here pi bonds is shifted over hydrogen. So hydrogen is forming like this. Here this sigma bond is breaking like this. So here pi bond is generated like this. And here this pi bond is converted into attached to A. So here sigma bond is there. So here 6-member transition state is there. Applications of pericyclic reactions. It is useful in green chemistry. Green chemistry means chemistry which involves without hazardous to environment. Many main application of pericyclic reactions. Here no side products are obtained due to cyclic transition state. As you can know that many reactions are formed and having side products also, but in this type of reaction here side products are avoided because of cyclic transition state. So you can get better yield for any reagent. It is useful in photodynamic therapy. Light is used to destroy tumors by the action of singlet oxygen generated by photosensitized reactions of triplet oxygen. Here photosensitizer includes tetraphenyl porphyrin and methylene blue. It is also useful in photodegradation of many substances. Like photodegradation means due to the presence of light, decomposition of various chemicals takes place. Like for example, polyvinyl chloride is used in medicine bottle are often made with darkened glass to prevent the drug from photodegradation. Here I am taking references from Claydon, Greaves and also from pictures from Wikipedia. So you can just go through it. Thank you all for listening me. Thank you.